Lesson 5.6 is graphing inequalities into variables. In this lesson, you will learn to graph linear inequalities on the coordinate plane and solve inequalities by graphing. Your vocabulary for the section is boundary, half plane, closed half plane, and open half plane. Okay, we'll touch on this more and go through the steps, but I'm just going to read through them really quick right now. So, the steps to graphing linear inequalities. Step 1, graph the boundary. Use a solid line when the inequality contains less than or equal to or greater than or equal to, and use a dashed line when the inequality contains less than or greater than. Step 2, use a test point to determine which half plane should be shaded. And step 3, shade the half plane that contains the solution. So, in order to do this, I want to be able to graph this line as if I was graphing 2y minus 4x equals 6 to start. So this is going to be, if I graph this, this will be my boundary. So to graph this, I want to get y by itself, so I'm going to add 4x to both sides. So I get 2y equals 4x plus 6. Getting y by itself by dividing everything by 2, I get y equals 2x plus 3. So now this is in y equals mx plus b form. So b, which is 3, is my y-intercept. So that's going to cross there, and my 2 is my slope. So that's same thing as 2 over 1. So it means it goes up 2 and forward 1 from this point. So up 2, forward 1. And it follows that pattern. Now, because our inequality is a greater than, it doesn't have that or equal to, that means it's not including our boundary. So we're going to do a dotted dashed line through there. So this is our boundary. That's step 1. Now step 1 is done. Step 2 said to pick a point not on the boundary. Okay, and we're going to take a point. I like to use 0, 0 because it's generally the easiest. So if I take the point 0, 0, and I go in here and put in 0 for x and 0 for y, I get 0 minus 0 is greater than 6. 0 is not greater than 6, which means this side of the plane, anything I pick, any of these points over here are not going to work, which means this is not my solution, this side of this half plane, which means that the other side of that is my solution. So I want to shade this half of the graph. This is my solution. Okay, so that's the answer to number 1. For number 2, it's the same idea. We want to find the boundary first. So to do that, I want to get y by itself. So to get y by itself, I'm going to subtract x to both sides. I'm going to graph it as if it was equal. So I subtract x. So I get 4y equals negative x plus 2. And divide everything by 4. And I get y equals negative 1/4 x plus 1/2, which means it starts at 1/2. That's my my b. And then my slope is 1/4, negative 1/4. So that means it's going to go down 1 and forward 4. So down 1, forward 4 from there gets me here. Or I can think of it as up 1 and back 4. So up 1 and back 4 would take me here. Okay, in this case, our line, our inequality, it has an or equal to. That means we're including our boundary. It can be on the boundary. So we want to draw a solid line going through these points. Okay, so that's step 1. Step 2 is to pick a point. So again, as long as 0, 0 is not on my line, I just drew the line very poorly here. It's not really on it because the line is really up there. So I can use the point 0, 0, which is the easiest to calculate. You can use another point too. But if I put in 0, 4 times 0 greater than 2 or equal to 2, I get 0 is greater than or equal to 2. Now again, I got a statement that is not true. 0 is less than 2, which means I don't want to shade the side where it's not true. Anything down here is not true. If I had picked a point up here, let's say I picked the point 1, 2. This will give me a true statement. So if I put in 1 for x and 2 for y, I get 9 is greater than or equal to 2, which is true. So any point I pick on this half is going to be true for this statement. So that means that is my solution up here, this half. So this is the side I want to shade of my line. Also, any point on the line would also give you a true statement. But anything below this particular line will not work. Okay, so example 3 says, use a graph to solve 2x plus 3 is less than or equal to 7. Now in this one, I only have one variable, so I can isolate that variable first. So to do that, I'm going to do minus 3. So I get 2x less than or equal to 4, and then I can divide by 2 and say x is less than or equal to 2. So if I want to graph this boundary, I'm graphing it as if it was x equals 2. So to graph x equals 2, that's anywhere that x is equal to 2. So since this is 2 on the x-axis, anywhere along this line going up and down, x will be 2. So this is where I want to draw my line. Because this is greater than or equal to, that means it's going to be a solid line. So I'm going to just draw my boundary right along here. Not that good. Okay, and then I want values that will make this true. So again, I'm going to use 0, 0, because when you put in 0 for a number, it makes it super easy because it just cancels that out. So you get 3 is less than or equal to 7. Now this time it is true. So because I got a true statement here, I want to shade the side that's true. So anything to the left of this line is going to give me true because that one point to the left of the line is true. So this is the side I'm going to shade. So just looking at the graph, you can also see that any value where x is less than 2 is a solution. Any point you pick. So we're going to say our solution is x equals 2. Okay, for example 4, Ranjan writes and edits short stories for a local newspaper. It takes him about an hour to write an article and about a half hour to edit an article. If Ranjan works up to 8 hours a day, how many articles can he write and edit one day? So let's call writing x and editing y. Okay, it takes him an hour to write. So we're going to say x times 1, an hour per x. And then he also has time to edit some. And it takes him half hour to edit an article. So that's going to be 1/2 times y, the number of articles he edits. And he says in total, those number of hours is going to be up to 8 hours. So it's going to be 8 hours is going to be the max. That's going to be the greatest. So this is what I want to be graphing. So if I want to graph this, I want to get y by itself and get it into y equals mx plus b. So I'm going to subtract x from both sides. So when I do that, I get 1/2 y is less than or equal to negative x plus 8. To get rid of the 1/2, I'm going to multiply both sides of my equation by 2. So when I do that, I get y is less than or equal to negative 2x plus 16. So to graph this inequality, I'm going to graph the boundary as if it was an equal sign. So to graph this, it has an intercept of 16. So I'm going to start on my y-axis at 16, and then it has a slope of negative 2, or negative 2 over 1. So it means it goes down 2 and forward 1. So from there, I'm just going to follow that pattern, down 2 and forward 1, until I get down to here. And this isn't or equal to, So that means I'm going to draw a solid line through my points. And then I want to know where I'm shading this. I'm going to pick a different point this time just so you guys can see. So if I put in the point 2, 2, for x and y, I have 1 times 2 plus 1/2 times 2, and I want to know if that's less than or equal to 8. So I get 2 plus 1 is less than or equal to 8, and that is true. I say 3 is less than or equal to 8. So that is the area that we want to be shading. So inside of here. Now, he can't read or edit negative numbers of articles, so we're not actually going to shade those other parts. We're just going to shade inside the triangle there because we can't go into the negative. Okay, so that is lesson 5.6, and if you have any questions, let me know in class.